Hello students, this is our class for sequence. In general life, sequence means succession of events or object. In another words, we can say that sequence means ordered list of events or objects. But here in mathematics, we will define sequence in different way. Here, sequence is a real valued function, and sequence is defined as a function as having domain set of natural numbers and codomain as a subset of real numbers. This means a sequence is a function that function having set of natural number as a domain. We can take example. See, this is the sequence 1, 1 by 2, 1 by 3, 1 by 4. See, all these are real numbers. This is here, and this is a set of natural number. Now, what we have done, mapping of 1 is 1, mapping of 2 is 1 by 2, and mapping of 3 is 1 by 3, and mapping of 4 is 1 by 4. This means here s is a function, this is s, here s is a function which is taking 1 to 1, 2 to 1 by 2, 3 to 1 by 3, and 4 to 1 by 4. This means here sequence is a function having image of 1 as 1, image of 2 as 1 by 2, image of 3 as 1 of 3, and in general image of n as a 1 of 1 by n. So we will write the first term by s1 having value 1, and second term of the sequence s2 by 1 by 2, third term 1 by 3, and nth term by 1 by n. See here, so sequence can be written as writing the general term 1 by n only, because all the terms can be calculated by putting n equal to 1, 2, 3, 4, etc. So sequence is a function, it is a real valued function which can be defined from set of natural number to any subset of set of real number. Let us move to next topic, which is bounded sequence. Making the matter more clear, I have taken one example. Sequence is 1 by n only. See, here we can find that every member of the sequence is less than or equal to 1. See, first member is equal to 1. Second number 1 by 2 is less than 1, and see. So I can say that every member of a sequence is less than or equal to 1. I can write it like this. I can write this in this way, or I can say it in this way, that in another way, that the sequence 1 upon n is bounded above by 1. Now I can again repeat. If every member of a sequence is less than some number, then you can say that this sequence is bounded above. For example, in this sequence, every member of the sequence is less than 1. So we can say that this sequence is bounded above by 1, and this special term is defined by k by. Now we can define what is the meaning of bounded above. Any sequence will called bounded above if there exists a real number k1. This means if we can find a number k1 such that Sn is less than equal to k1 for all n. Here k1 is known as upper bound of the sequence. in just discussed example, 1 is working as a upper bound. One thing to note is that upper bound of a sequence is not unique. We may have many upper bounds. For example, in previous example, 2 can also work as a upper bound. 3 can also work as a upper bound. And second thing to note is that it is not necessary that every time upper bound will exist. This means for some sequences upper bound can exist, and some sequences it may. Let us move further. Consider, now we have reverse case. See, every member of sequence is greater than this number 0. See, take any member of the sequence, it is greater than 0 whatever value of n is there. So I can write that 1 upon n will always greater than equal to 0. So we can say that this sequence is bounded below by 0. and this number can be written by constant k2. So we can say that if we can find a special number k2 which is less than or equal to every member of the sequence, then such a number is called lower bound and sequence is called bounded bill. We can summarize it like this, that any sequence will called bounded below if there exists a real number k2 such that k2 is less than equal to Sn for all n, and k2 is called lower bound. This means if you have to show that any sequence is bounded below, then you will search for k2. Let us move further. We have now definition of bounded sequence. Any sequence will be called bounded if it is both bounded above and bounded below. This means if you can find k1 and k2 both real numbers for a sequence satisfying this condition, then the sequence will be called bounded sequence. You can define bounded sequence by another definition, which is this: if you can find k satisfying this condition, what it means, you can write it like this also. Sn is minus k and this is k. So if you can find a k satisfying this condition, then you say that sequence is bounded. This means if you want to prove any sequence bounded, you have to search for lower bound and upper bound. Now another thing to notice is that lower bounds are not unique. This means there can exist many lower bounds for a sequence, and second thing is that every time it is not necessary that lower bound will exist. For some problems lower bound can exist, for some may not. For making the concept more clear, let us take one more example. Consider example n square. This is sequence having general term as n square, and you can write it in expanded form like this. See, every term of the sequence is greater than 1. See, every term of the sequence is greater than 1. So here value of k2 is 1. This means I can write that Sn is greater than equal to 1 for all n. For all n means every member of the sequence is greater than or equal to 1. So I can say that as this sequence is bounded below. Now let us check for bounded above. So here we cannot find any number k1 which satisfies this condition. See, we can't find such number k1 which satisfies this condition, because this sequence, every time this sequence is increasing, so you can't find a definite number. So here we fail to get this number. So we can say that this sequence is not bounded ever, or in other words we can say that it is unbounded. Let us define the definition of unboundedness. Sn is called unbounded if either it is unbounded below or unbounded above. What it means? That if a certain sequence is not bounded above, this means unbounded above, then you will say that this sequence is unbounded. Now let us define infimum and supremum. This is the sequence, and here this shows a set of upper bounds, and this is the least upper bound, and the name of least upper bound is supremum. This means supremum is that upper bound having least value in set of upper bounds. Similarly, this is the set of lower bounds, and set of lower bounds all are lower bounds, and its greatest lower bound in the set of lower bound is known as infimum or glove, greatest lower bound. Let us take one example. Consider this sequence. Now see, if n is a natural number, then we will have always this case, because n is natural number, so it will be always greater than 0, and it will always less than n plus 1. If I divide this inequality by n plus 1, so I will get this. So I have found k1, which is upper bound, and I can define k2, which is lower bound. So in this question I have calculated upper bound and lower bound, so I can say that this is bounded. This means if in a certain question you have to prove that the sequence is bounded, this means you have to search for k1 and k2. Thank you for watching.